Okay, so thanks for the introduction and the opportunity to be here together with you as SCCC. I really like that our names are quite similar and coherent, so that gives more opportunities to collaborate and looks very nice. So I came from ENCCS, and in this talk, I would like to give a little bit of a hint in this kind of joint webinar, or like a webinar, get your platform for what is ENCCS and what we can do for the SCCC stakeholders and SCCC customers. So, but before going into that, I would like to give you a little bit about a bigger picture for what is ENCCS and how is it related to this bigger picture in EuroHPC Joint Undertaking. And Joint Undertaking is an initiative between different European countries and the EU itself to build that world-class supercomputer centers. And that has started already almost a decade ago with this initiative, with the planning and so on. And it worked, and it let Europe has leading positions into supercomputers powers when it comes to the number of flops that it can offer for the European users. Those computers are scattered across Europe, and they are kind of funded by European Union, plus also some local funding for the hosting countries for that. And as a result of that, you need to build competence centers that can train customers can brokerage services of these HPC resources for customers, and customers can use it in an easier way than as if then you don't need to be so familiar already with many aspects, like, for example, SSH, for example, and compiling codes and so on. So these competence centers are helping you to do these things, plus also do other services and brokerage to other offers and services that you can benefit you and your company. Research, this is open for SMEs and for big industry and academics and public authorities. And of course, you need to apply for time, get feedback and review for your application in order to get it accepted. And then you are granted time on the machines. Of course, so if these machines, so for people who are not familiar with, so this is like the supercomputers, which is like racks of computing power that has like house CPUs, GPUs, and interconnects. And these pictures are real pictures. So the big one is from Jupiter, is in Germany, in Aachen, I think, close to Aachen, in Jülich. And the one to the right bottom, it's LUMI. This is available in Finland. I'm just getting my laser pointer. And the one here, this word Leo is stands for Leonardo. And you can see N over A over there and so on. That one is hosted in Cineca in Italy. And each one has specific characteristics which allows users to test and to be able to host their development solutions on different modularities or different hardware. But before going that, so so as I told you here, there's like 37 countries that have this competence centers, and it happens that the ENCCS is one of them, which is represented in those brilliant people. And those people are having like diverse backgrounds, but which is integrating together in order to give the best for the customers. And we are united, as I like to say it like this, that we have a passion for supercomputing, all of us. And that picture was in the last kickoff meeting, and hopefully we have a refreshed one in the next kickoff meeting. And we stand for EuroHPC National Competence Center Sweden. So we have this nice name, ENCCS. So to give you a little perspective, so what is it doing? What we are doing, so we like to divide it into these kind of categories of like services, brokerage to services, where we help with access to the supercomputers you have just seen. And we give our services in terms of consultation services. And also we give trainings in order to educate the audience how to use these machines to the best. And of course, also related technologies to these machines. And we help you also either get the support from us or get the support from other excellence centers or other European support bodies that can help you in your actions. For example, like code porting, for example, then we help you into that. In order to do that, we leverage a few methods. So of course, we have like traditional high-performance computing. Probably you heard about it from CFD people, computational fluid dynamics people. They do a lot of this, and also material science, where I came from that background already myself. Or you have a lot of data, so you want to leverage that, or like what's called like big data, and then you do this high-performance data analysis. Or you already came from, or you have a methods that is related to emerging technologies, where quantum computing, for example, it sits there. Something similar relevant to the audience here is RISC-V, for example. And for that, we leverage infrastructure. And infrastructure here, we like to divide it into like a hardware infrastructure, which is the devices that we help you leverage it, but also the network that we are building over the years, where sometimes your service could be best suited by asking some other, previous client or some other partner and so on. So we have this. So for example, with our partnership here, our communication with SCCC, we can, when the customer use case is matching with SCCC, then we connect with SCCC bodies, of course. So this is like an example for that. And to the left side here, it's like you can see what we can call it like the added value to the customer in terms of these aspects, hands-on skills or consultancy, proof of concept, and this gives you more of a clear path to HPC. ENCCS by itself is kind of joint between NICE, which stands for National Infrastructure for Supercomputing in Sweden, and RISE, which is Research Institute of Sweden, where I'm sitting right now and I'm presenting. So the team is divided between the two institutions, building this competence center together. And of course, like funded by those bodies with all those logos below. We building on these services. So it happens that we had many success stories over the years. We have been operated right now for this is year number 7, and we had helped many of the customers, like those ones in this mesh are part of them, where they are spanning different domains. So when it comes to material science, chemistry, deep learning, energy storage, X-ray imaging, biotech, and logistics, drug design, and so on. So it happens that our customers within the Swedish ecosystem are spanning many domains. Meanwhile, we also give trainings, and that's a little bit of a matrix for our trainings also over the last 7 years, where we managed to train around or more than 2,500 people in our joint trainings or standalone trainings. And these trainings spanned many areas. It ranged from programming libraries to accelerated programming, like, teaching them how to do GPU programming, to emerging things like technologies like quantum computing, for example, to also organizing summits or days where we, industry days, for example, where we advertise our services to the industry and also get like invited talks from the companies we supported and we helped to make the ecosystem aware of what can be done using HPC. Moreover, also I want to highlight that the domain expertise and the domain trainings are also big parts of our offerings. This is very important because it touches the customer directly. So, but we are not alone in this. So the EuroHPC GU has made this to do this kind of 7 pillars to augment them together. And these 7 pillars, like you see here from the left, like skills to connect it with infrastructure, technology, applications, and cooperations, and federated access infrastructure. So that's quite important when it comes to the ecosystem. So also we have, I think I forgot to put it here, but we have HPC portal, which unites us, including to include and to do the offerings of services and also things like trainings and so on. So if there is a training that we don't have or we don't offer in CCS, probably another competence center is providing it. So the most important part is that we are not replicating their effort, but we are integrating their effort. So that's where I encourage you also to go to that website, and I will make sure to update the slides before sharing it for that HPC portal, for example. And the ecosystem by itself aims to do this kind of connection between the supercomputers and the users in order to give an impact. So we can think about it that here is in the left, we have the building blocks for what we want to do together in order to give the customer an impact over here on the right. And that is done through the network of, for example, the competence centers plus the partners that I will be giving an example about in a second, or at the end of the slides. But to go back to the supercomputer centers, so within the years, so right now, in like almost after 7 years of this project, or this supercomputers are up, many of them. So in the last top 500, they had scored quite high. So we have LUMI scored like 5th over there, and Leonardo number 7 over there, and so on. So this really enabled quite a good competitive edge for Europe here in that sense. And of course, like went in line with the sovereignty and European sovereignty when it comes to the models taking out here, or the simulations and so on. So these devices, if you go a little bit more in details into them, they, as I mentioned, they have different modalities, then they can satisfy different needs for different use cases as the users have. So for example, here Jupyter, you have NVIDIA Grace Hopper, you have in LUMI, we have AMD powered GPUs and CPUs, and we have these 2 partitions, LUMI C for CPUs and G for GPUs, and so on. And I think also we had Intel somewhere here in Leonardo and NVIDIA. And in Jupyter, I think there is also an ARM partition. And there's the one in Portugal, there's also ARM partition. There is also RISC-V partition coming up in Jupyter, as far as I know, as well. But I cannot go out from here without telling a little bit about the AI factories, which is our sibling kind of center, you can say. And this picture is the first AI factory waves that was announced a couple of years ago. which is an important piece to leverage the AI transform and to build on top of that for sovereignty actions and also for to be closer to customers and use cases. And it happens that we are lucky in Sweden to have one factory here called Mimer, which is up and running right now at the moment when it comes to services. And the hardware, I believe it should be available within the year somehow. Worth mentioning also that we work with Mimer to help customers. So in case a customer wants to reach out to them and you know only about us, come to us and we can connect you, of course. So I wanted to touch here a little bit about what can HPC bring to the audience here, where the audience here is involved in semiconductor design, as far as I know. So as something that we can complement with, so we believe that HPC can deliver speed ups to your simulations, and you need simulations, and then you can shorten time to design and have less trial and errors, and then you can have this less points for your design space, and then you can go on with your proof of concept or your design. Design is expensive, or hardware is expensive all the time, then that's where simulations bring a value. So if you're starting from the very beginning here, so I think like when it comes to computational lithography and the SPICE models, so these are few examples of few tools that accelerate that, and hereby it accelerates this design on GPUs, for example. And that acceleration is not only a speed up, but also it allows you to test and do more with that we were not able to do before, even in a workstation and so on. So, for example, NVIDIA has announced that CU-LISU, I think, which is a very good library that can accelerate design. And this one is adopted in few tools that one of them are used by SML already. To the right here, that was an algorithm to work in the mask problems using GPUs. This one was by Synopsys for SPICE simulations, to accelerate the SPICE simulations. And that one was announced together, announcement joint by NVIDIA and Cadence, almost for the same CU-LISU, plus also using generative models for that. Hereby, this is like more for RTL simulations on GPUs and CPUs. And also how to, for the one to the left here, it was more of from Verilog to CUDA for batch simulations. And the one here to the right, it was more for how to run and very Virilator, I think it was for large-scale designs. And the one over here to accelerate RTL for large-scale designs. That, for example, they used this Virilator booting Linux, where they recorded the 7x speedups and 20x speedups for core mark and so on. I'm not familiar with these aspects so much. I'm just like a pop science reader for that, but it happens that I found those nice results that could help customers adopt HPC for such reasons. When it comes to EDA, LLM is playing a big factor here, and HPC and LLM are interconnected. I mean here, interconnected in means that HPC can run LLMs. And of course, we have AI factories that can help in that. But at the end of the day, you run it on a machine that it's either this machine associated to an HPC center or associated to an AI factory. You can do basically the same. And for that, for example, there is it attracted my attention. There is like many projects going on for that. So I think there is one impressive one called ChipNemo by NVIDIA here, where you can have train up models that can do many trials and errors or many iterations when it comes to your chip design. There's also another impressive project called Alpha Chip that was given by Google. That was back in 2021, and that is the claim that using some reinforcement learning agents, you can generate full floor plan within 6 hours. It's open source, and things are also tested here in RISC-V, so please go on and you can test it yourself. There's also things like called RTL coder, for example, which also can do Verilog generation for you. And these things can be also accelerated on HPC. Also worth reading this survey where it can tell you about LLMs for EDA on the left over here. When it comes to chip design or TCAD simulations, this is kind of the closer to my background. So also there is recent announcements that was 2 years ago by Synopsys Centaurus that to accelerate the finite volume method or finite element method simulations that are taking the huge chunk of time over there on GPUs, which can be translated to run on the HPC setup to accelerate your chip design or finite element method. Then you get a faster time to solution. I used to do these simulations on a workstation, and it was taking days. But I can imagine right now when it is accelerated on high-end GPUs, like the ones we have in Leonardo, for example, or LUMI, this can really make a big difference if once given that it's like 10x reduction or 10x improvement. I can say I want to highlight also that within the last 5 years, there are open source tools when it comes to TCAD simulations are getting a lot of attraction. So, for example, there's these 2 tools, one called DevSim and the other one called Sharon TCAD, which are from 2 big labs, and they can basically do very similar aspect to what Synopsys can do, for example, when it comes to Synopsys Centaurus, for example. And given that they are open source, so there's no license roadblocks over here, so you can run them on your HPC machines as well. And the team can help you compile those and make them runnable. They're open source and available here. To the right over here, this comes like more of atomistic simulations where it can be required or can be also essential for some of the workflows for some semiconductor design. And for that, they use atomistic methods like density function theory or type binding in order to accelerate your design. Then you can get like some transport characteristics, IV curves, and so on. And resistivity, capacitivity, and experiment more of a low-level design. Hereby, there's few examples for EDA acceleration on HPC. So, and I got from that few examples that AWS are doing, for example. So AWS had made some effort with Cadence here to accelerate his Jasper to, for example, like 960 cores. This is talk about CPU cores. I think this was ARM cores, but maybe I'm mistaken, but I will double check some of that. So this one, for example, allows that in your HPC devices, you can easily get hands on 960 cores, so you can do the same experiment or even higher. Same also here for the right here, Jasper Gold again. So this is another example. And the one here and left bottom here, this one is kind of open stack for this Yushi HQ, which is a TCAD simulation pipeline as well. that is used in production for some RISC-V vendors, for example, and it is open source, and it can be scalable as well to your HPC machines size. The one to the right is very specialized to RISC-V processors, so and it's also open source. This one is also an explanation about this open road, which is an autonomous RTL to GDS2, and they have this nice workflow where they illustrated how with no human in the loop, you can have this 24-hour RTL to GDS2 turnarounds. And here's a few details. Please go visit these links, then you can learn more about it. Then from Verilog to GDS2. One also want here as well to highlight like how from Python to lab you can do this designs for new ideas in chips, like for example, if it is photonic chip, or analog, or quantum, or MEMS. So you can use Python or YAML files formats in order to define your parameters and go on with simulation. And then you can employ many tools over here. And for example, this can also integrate it with small simulation toolkits, like those ones, where I will give a quick overview about them in the next slide, where those ones, you use them for specific tasks. For example, this one MEEP is to get to solve for time-dependent, Maxwell solver. It's a Maxwell solver, Maxwell equations. And this one, Palace here, for example, this if you are into photonics and you are doing this designs, and maybe you don't have a license for COMSOL, then you can use it, for example. So it's a finite element method electromagnetic computational electromagnetic solver. And DevSim, I think I touched upon about it, and there's other ones like this numeric, for example, and so on. So all in all, what I wanted to say here as a take-home message is that SCCC and ENCCS here together, we can help customer in their journey. So that it's a semiconductor SME, I imagine, and it can be, you know, some example of those or something else as well, where they bring their challenge to SCCC, of course, they identify if there's a simulation needs and or trainings that are needed when it comes to these computational needs, and then we together at the ENCCS with SCCC, we narrow down the requirements, we see how we can help. And then if that is a simulation need, and then it needs your HPC access, and we help you to get the access, but we are not stopping there. We help you to maximize your usage of it and compile your own code, or get the code that you wanted to run, either if it is free or commercial. Then we help it into our the resources that we can help you have access to. And one of these resources, by the way, I highlighted here in yellow, is Arrhenius, which is here in Sweden. It should be up and running within the second half of the year. And it is important for a few customers who care about data, where their data and simulations live. Then if they are a Swedish company and the device is here in Sweden already in Linköping, then it makes sense for some of them. Then I wanted, before I thank you, to highlight that please feel free to connect to us on LinkedIn or send us an email, or listen to some of our podcasts that we had this podcast where we offered it, which is called Supercomputing in Europe, where it happened that a few of it are touching up on semiconductors, of course, and we get a maximum, like bring more in that. And if you know a good speaker, of course, please reach out to us. Then we highlight semiconductors in Europe and semiconductor simulations in specific. and I wanted to thank everyone. But before that, I remember that there's something in the appendix that I wanted to tell you, that if it happens that you came with your code and but you need even more support than the support we are giving you, we can help you get connected with many other efforts in Europe. For example, this one called Epicure, which can have a dedicated professional with you for 5 or 6 months to help benchmark this code, optimize this code. Then it can get the best or it can get high benefits from running on HPC resources. And I want to thank everyone. Thank you.